Hello! In this video I'll be going through the process of adding a device to Rollout's configuration. The Rollout server and device are both Ubuntu 12.04 64-bit servers in a cloud environment. The Rollout server was installed in a previous video. Today I will be running all commands as root, and on the server we have installed Rollout in /data/rollout. In this directory there is a fragments subdirectory. In the fragments subdirectory is where the device configurations should be stored. When cloning the Rollout Git repository for the first time, a few demo configurations are included. You can safely remove the demo entries from the configuration files. The files that have the demo configurations are rollout.cfg and fragments/internal. I've already removed the demo declarations from the configuration files for this video. I have created a directory structure for the location of the device declarations under fragments, and that is DigitalOcean/sanfran, or san_fran. These VMs are in the DigitalOcean cloud, located in San Francisco in the US. After the sanfran directory, I've created two other directories, prod and non-prod. In those directories you can see the two files, infrastructure and test. For this video we'll focus on the test file. This is where the device declaration for rollout-clt is defined. Rollout-clt is our server that we're installing the Rollout client on in this video. If we look inside of the test file, we can see that we're declaring the device rollout-clt. It also inherits the standard class. Let's see what the standard class does. The standard class is located in the rollout.cfg file. In the standard class, we are setting the name servers. Then we are making sure that the services for SSHD, SNMPD, and NTP are started and set to start at boot time. The 1 represents true, 0 for false if you want the services not to run. Next, we are making sure that there's some packages installed for each Rollout client. Then we're making sure that the admin group exists, but we don't care what the GID is. So we're letting the OS decide what the GID should be. Then we're ensuring that the test user is created on every single server running Rollout, with a name, home, groups, and the password entries. Again, we're not worried about the UID or the primary GID of this user. We'll let the OS decide that. Then we're setting up sudo privileges. Here we have the admin group that is allowed to run all of these commands, as we have the groups for test user. The test user belonging to the admin group would be able to run all of these commands. Then specifically for the test user, the command /sbin/reboot is allowed. So now we have seen the inherited configuration for any class or device that inherits the standard class. And back to our device declarations, or declaration. So we've been through the standard class in the device rollout-clt declaration. Next, we're looking at the interfaces. We are configuring ETH0 as the primary interface. This primary designation is what will go into /etc/hosts and also be used for the primary IP address when configuring other network-related objects for these devices, or in this case, for Rollout-CLT. Then we're setting up the IP address, netmask, network, broadcast, gateway, or in other words, the default route. And that's all we have configured so far for Rollout-CLT. Now we need to install Rollout from the Rollout server. First, on the client, we need to install a few packages first. Here we're installing these packages. Now that they're installed, we can go ahead and pull down the Rollout script and install it onto the client. So normally I'd have an automated build process that adds these packages at build time. The method would of course depend on whether I was using something in the cloud or something like Kickstart or Jumpstart for physical servers. Now that we have those packages installed, we can install Rollout, as I said previously. In order to do that, we need to know the URL of the Rollout server and what port it is listening on. In this case, we're talking to Rollout-serve on port 80. Now we have network connectivity ensured, at least for ping. We can attempt to download using wget to standard out the URL of the Rollout serve, and then the Rollout script itself. This is pretty much the only thing that you need to install on a client in order to have it run Rollout. Then, because we're downloading to standard out, that's what the minus capital O minus specifies, we can pipe this to Perl and tell Perl to run from standard in. That's with the dash. That's the first dash here. Then we want to tell it that the URL of the Rollout server is HTTP, and we give it the same URL that we wgetted down, and that is the URL. Notice we're not including the script here, just the base URL. Then we're giving it an option to only run the setup step. That's the only thing we want to run right now. So, there we go. It is now installed. We can run the rest of the steps now. If you'd like to see the changes that are going to be done before running the rest of the steps, there are a few different modes. The -s argument means safe mode, or don't make any changes. The -v argument will provide a more verbose method of what is going on, regardless of whether or not -s is used. So here we can see that we have network changes, some packages are being installed, and then we're going to update the message of the day with what we've changed. In order to do that, we just take off the -s argument to apply these changes. So, there we go. Quite a bit of stuff happened. Looks like everything was installed, so let's check now with the -s flag. Okay. Notice that the network settings were never applied. In order to apply network changes, we need to force this step with the -f argument. Also nominate which step is being forcefully run. So rollout -f, and we want you to forcefully run the network step. Okay, so forcefully running the network step. Network configuration has been changed. You must restart the interfaces manually to apply these changes. Also, we can see that these services, SNMPD and SSHD, don't seem to exist. And the most likely cause is that we haven't installed the actual SNMP daemon yet with the packages that we specified in rollout.cfg, and we've also given the wrong service name to have start. So, if we go back to the rollout server, we modify the configuration file. The standard class is what we want to edit. Alongside SNMP, we also want SNMPD. And then we want to change the service just to SSH, as this is Ubuntu, and that is what is required. So if we run just the services again, so -o services, we will see that SNMPD still does not exist, as we have not changed or installed packages yet. But SSH looks like it's started. There we go. It is indeed started, and the service is updated to start on boot, which it would have already been by default, which is why we don't see the services changing here. So, in order to get the services up and running, we have to install packages as well. Now it looks like everything is good again, or good for the first time, so we check it with -s. And there we have it. So nothing was done, nothing needs to be done, with the exception of the message of the day step.